All right, so this is an in-class practice for parallelograms, so there's nothing new that will be in this lesson. It's just practice, so it should go pretty quickly for a screencast. All right, so first off, I have to read the directions. It says find the measures of the numbered angles for each parallelogram. So please remember these are parallelograms. All properties of parallelograms apply. All right, so first thing I'm going to do is I'm going to get angle 2 actually because I see a linear pair right here. And that does not have to do with the fact that it's a parallelogram. That has to do with the fact that that's a straight line. So I can do 180 minus 73, which is 107 degrees. So I can say angle 2 is 107 degrees. All right, now the next thing that I remember is that this is a parallelogram. So these lines are parallel, and I see a transversal right here. And I know that alternate interior angles are congruent. So I know this angle is congruent to this angle. So I can now say that angle 4 is 35 degrees. All right, I'm also going to fill in the fact that this is 107 and this is 73 to try to help me get what I need to get. All right, so that was helpful because now I see angle 1 right here. I see another triangle that is being, or not another, but I see a triangle that's being formed and only missing one angle. I do notice that angle 1 and angle 3 are congruent because they're alternate interior angles, but I don't have angle 3 either. So I'm going to get angle 1 here. I'm going to do 107 plus 35. It's 2, carry the 1, that's 142. And then I'm going to do 180 minus that. 180 minus 142, that's 38 degrees. So angle 1 is 38 degrees, and alternate interior angles are congruent, so angle 3 is also 38 degrees. All right, let's try problem number 2. All right, so once again, I have a parallelogram. So I have a parallelogram here. I know that these two lines are parallel. I know the other two lines are parallel also. And here is a transversal, and I know alternate interior angles are congruent. So I know this angle is congruent to this angle. So this is 37 degrees also. So angle 2, 37 degrees. Now I can use my other parallel lines. These two lines are parallel, this line and this line, with this transversal. And then I have these two alternate interior angles congruent. So this has to be 63 degrees. So angle 1 is 63 degrees. All right, now I can use my triangles to help me get the one missing angle in this triangle. So I'll do 37 plus 63. That's 0, carry the 1, that's 0, 1, 100 degrees. And then 180 minus 100 degrees is 80 degrees. I know opposite angles are congruent, so this must be 80 degrees also. I could have started by using that triangle to get that. But I don't know why I just didn't choose to do that. Okay. All right, let's move on to the next problem. So it says, in this parallelogram, solve for x and y. So I know opposite sides are congruent in a parallelogram. Parallelogram here. So I look at that equation, and that's 2x plus 6 is equal to y plus 5. I'll write it down. 2x plus 6 is equal to y plus 5. If you look at that, that has an x and a y in it. I can't solve it right now, so I'm going to look to see it. My other side, these two are congruent. Those both have x's in it, so I can solve for x using those two. So I'm going to do 5x plus 12 is equal to 4x plus 32. And I'll solve for x in this equation. Subtract 4x from both sides. That's x plus 12 is equal to 32. Subtract 12 from both sides. And I have x is equal to 20. All right, now I need to solve for y. And as you can see, I know that x is no longer a mystery. X is 20, so I can plug it in here. So I'm going to do 2 times 20 plus 6 is equal to y plus 5. So that's 46 is equal to y plus 5. Subtract 5 from both sides, and I have y is equal to 41. So we have x is 20 and y is 41. So sometimes you have to look because you have to solve for one variable before you can solve for another. All right, problem B. Did I make a mistake there? No, I didn't. 2 times 20. There we go. No, we're good. Okay, moving on to the next one. All right, so first thing that I notice is that I have alternate interior angles that are congruent and opposite angles that are congruent. Let's say I notice opposite angles are congruent first. Once again, notice here you have a 3x plus 30 is equal to 5y, and I can't solve that right now. So I also notice that I have alternate interior angles congruent. So I'm going to start by doing 2x is equal to 30. Divide by 2. And I have x is 15. All right, now I can go back to my other equation that I wasn't able to solve yet. 3x plus 30 is equal to 5y. And now I can solve that because I know x is 15. So I'm going to do 3 times 15 plus 30 is equal to 5y. 45 plus 30 is 75 is equal to 5y. Divide both sides by 5, and I get y is also 15. By coincidence, there's x and y. All right, next one, in the parallelogram again, solve for x and y, state the reason for your equations. Okay, and we can cross off state the reason for your equations. That is something that we used to do, but we don't have to do that anymore. Okay, so we have sides again. I know opposite sides are congruent. So these two sides are congruent. That's x equals y plus 6. Can't solve that yet. So now I'm going to look at my other equation. That has an x and a y in it also. So whenever that happens, you're going to write both down. X plus y equals 14. This is called a system of equations. It's when you have two equations with two variables. To solve a system of equations, we can either use substitution or elimination. In this case, we're going to use substitution. We use substitution due to the fact that we already have a variable solved for. What I mean by that is, if you look at the first equation, it says x equals. If you see an x equals or a y equals, you're going to use substitution. Here's what we're going to do. We're going to see what x is equal to. It's equal to y plus 6. And what that means is that anytime we see an x, instead of writing an x, we can write y plus 6. Do we see an x anywhere else? We see it in this equation. So what we're going to do is, instead of writing x right here, we are going to write y plus 6. So I have y plus 6 instead of this x right here. And then plus y, that's this plus y right here, equals 14. Now, if you look at that equation, you can solve it. Combine like terms, you have a y and a y, which is 2y, plus 6 equals 14. Subtract 6 from both sides. That's 2y is equal to 8. And then divide by 2, and we get y is equal to 4. Now we need to solve for x. To solve for x, we can go back to either one of our equations. I'm going to go back to this one. I know x is the same thing as y plus 6. So I'm going to do 4 plus 6. And I get x is 10. Okay. Let's try a few other equations. So please notice that this has the same directions from number 4, because this is still number 4. They're all parallelograms on these two right here. Okay, so I'm going to look to see what I have. I have opposite angles and I have same side interior angles. So if you look, your opposite angles are congruent, but they have an x and a y in it. I could write that equation right now. 6x minus 12 is equal to 4y. But I can't solve that right now, so let's see if we can do another equation. Well, I see that both of these are next to each other. They're same side interior angles, and they both have a y in it. I know same side interior angles are supplementary. So I'm going to do 4y plus 12 plus 4y is equal to 180. Combine like terms, 8y plus 12 is equal to 180. Subtract 12 from both sides. 8y is equal to 168. And then divide both sides by 8, and I get y is equal to 21. So now I know y is 21. I can box it here too if I like. And now I can use that to solve my first equation. So I'm going to do 6x minus 12 is equal to 4 times 21. 6x minus 12 is equal to 84. Add 12 to both sides. 6x is equal to 96, and then divide both sides by 6. X is equal to, 6 goes into 9 once, there's a remainder of 3, 36 6 times. So x equals 16. So notice sometimes you need a system, sometimes you don't. If you would have wrote this as your other equation, those two add to 180, you'd have to make a system. But notice we could avoid that by using both ones with y in it. All right, let's look at the next one. I see parallel lines, and I know alternate interior angles are congruent. So these two angles are congruent. Let's look to see if we can write an equation and solve that. 28 is equal to 3y plus 10. Yep, I can solve that equation. Let's do that right now. 18 is equal to 3y. Divide by 3. Y is equal to 6. All right, now let's look at our other equation. We have alternate interior angles that are congruent. So I'm going to say 5x plus y is equal to 56. This has an x and a y in it, but we know what we know what y is. Y is 6. So I'm going to do 5x plus 6 is equal to 36. Subtract 6 from both sides. 5x is equal to 30. Divide by 5. And I have x is 6. Okay, wait, that's a mistake right there. That was supposed to be 56. My bad. Subtract 6 from both sides and you get 50. Divide by 5, you get 10. Thought I made a mistake there. There we go, but I caught it. Okay, our last couple problems here for number 5. Find the numbered angles in each parallelogram. Then as you look closer, there's more information. So if you look at this one as a parallelogram with 4 congruent sides. If it has 4 congruent sides, that means that this is a rhombus. So now all properties of a rhombus apply. First thing I remember about a rhombus is that their diagonals are perpendicular. So these 4 angles are 90 degrees. So now I'm going to put angle 1, 90 degrees. All right, I also still know it's a parallelogram and alternate interior angles are congruent. So if this is 28, so is this angle. Angle 3 is 28. So here's something about rhombi that I have to remember, is that the diagonals also bisect opposite angles. So not only is this angle 3 28, but this angle 2 is also 28. That only happens in rhombi and squares. This is 28 also. So 2 and 3 are 28 degrees. Last but not least, I need 4 and 5. I'll start with 4. There's a triangle right here. It's only missing one angle. So I can do 90 plus 28, 180 minus that, or I can do the shortcut of 90 minus 28. If I do that, excuse me, I get 62 degrees. This is 62 because the angle is bisected, so angle 4 is 62. Alternate interior angles are congruent, so this is 62 and this is 62, or I could have used the triangles. Okay, next one, it's a parallelogram, but if you notice it has one right angle, that means all of the angles, all 4 angles are right angles, so this is a rectangle. And if you're like, wait, why? Because in a parallelogram, opposite angles are congruent, so that has to be a right angle. And same side interior angles have to be congruent. So this has to, they have to be supplementary. So they have to add to 180. So they have no other choice but be 90. All right, let's start by getting angle 6. I know that those two have to add to 90. 90 minus 41 is 49 degrees. So So angle 6 is 49 degrees. Another important piece of information about a rectangle, if you remember it, you'll probably get everything else right, is that diagonals not only bisect each other, but they're also congruent. So these 4 pieces are congruent. Why is that important? That's because I now have 4 isosceles triangles. I know that base angles of an isosceles triangle are congruent, so this is 41. Base angles of an isosceles triangle are congruent, so that's 49. These two have to add to 90, so this is 41. This is 41. This is 49. And this is 49. So now I have angle 2 is 41 degrees. Angle 4 is 49 degrees. Angle 3 is 49 degrees. And angle 6 I already have is 49 degrees. All right, last I need is 1 and 5. So I'll start with angle 1. I'm going to use my triangle right here that's only missing 1 angle. So I know they have to sum to 180, so I'm going to add 41 and 41, which is 82, and then do 180 minus that. That's 98 degrees. So this is 98 degrees for angle 1. Now I can use this linear pair to get angle 5, or I can use this triangle to get angle 5. 180 minus 98 is 82 degrees. So angle 5 is 82 degrees. All right, last but not least, we have another parallelogram here. All right, we have sides marked. We know opposite sides are congruent, so these 2 sides are congruent and these 2 sides are congruent. I'll write down my first equation. I have x equals y minus 2, and I can't solve that. If I look at my second equation, it's x plus y equals 8. That also has 2 variables in it, so I'm going to write down both. Once again, as a reminder, this is called a system. We're going to use substitution to solve for our system. We already know x is the same thing as y minus 2. So anytime I see an x, right here I can write y minus 2 instead. So I'm going to write y minus 2, instead of writing that x, plus y equals 8. 2y minus 2 is equal to 8. Add 2. 2y is equal to 10. Divide by 2. Y is 5. Now I just need x, and once again I can come back to my original equation. I know x is equal to y minus 2, where y is 5. 5 minus 2 is 3, so x is equal to 3. You could always check your answers by plugging them back in and making sure that your opposite sides